Yes, sir.
Hello.
Yes,
So
sir.
So heat is transferred.
yes, exactly. Heat is transferred. Now you do the same thing using one, that sometimes you see there are spoons with, cover, right? Like the part you are holding, that part we have is that covering of plastic, isn't it? In our house we have some, spoon which has at the end where we are holding it, there is covering of plastic. Have you ever seen that? Hmm? Like if I show you in the, diagram, spoon with insulation at the end. Okay, okay. So this is one example. We have insulation. Let's see more. There is anything. Okay, this one you see, it
Oh,
has,
yes, sir.
yeah, at the end it has plastic insulation, right? So
Yes.
if you hold it, then you will not feel that much heat, right? Uh,
Yes, sir.
the one you feel without the covering of plastic, right?
It
So
restrains.
yeah, so this one, this covering, this plastic covering is called insulator, huh? And
Yes.
here, this one, the metal one, it is good conductor of heat. Why this is working? The rubber one is working as insulator, and why this metal is a very good conductor of heat? There is reason. The reason is the structure. Their structure, metal, they have free electrons, right? In their atomic structure, they have free electrons which can move freely, and they carry the, you know, heat. They carry the heat. Okay, is it clear to you?
Yes, sir.
So that's the thing distinguishing between good and bad conductors of heat. Like wood. Wood is also insulator. We are having this one in our house. We have also see that my mom and the my spouse, they are also using some clothes, right, to hold the, hot container, right, so that the heat is not passing to their hand. Have you ever seen in your house that is called loosely called in Bangla? have
Yes,
you,
sir.
Yes.
have you seen? Yeah. So these are bad conductors of heat, huh? Clothes, huh? The dry clothes and wood, then plastic, rubber, glass, huh? These are bad conductors of heat. And good conductor heats all the metals. And some are very good conductors like aluminum, yeah, then copper, then the steel one. Yeah. These are very good conductors of heat. And aluminum is cheap. This one easily can be bent to make different kinds of containers. That's why aluminum is used mostly, right? The other metals,
Yes.
those are, little bit expensive. We have some, containers made from steel also. Mostly we are using from aluminum, right? Isn't it?
Yes, sir.
Yes, sir.
So you understood. I think you all understood the difference between good and bad conductors of heat, and you also understood why they are called them. Be good conductors and bad conductors of heat, right? Why? Why metals are called good conductors of heat?
Because they have free electrons.
Yeah, they have free electrons, and that is the reason why they are good conductors. And the definition should be like they can easily transfer heat
Or
energy.
not electricity,
Yeah,
sir. Electricity or heat.
yeah, it's about heat energy. Okay, it's about heat energy. We are dealing with thermal physics now. We are talking about thermal physics. That's why our definition will come by thermal energy, right? Or
Yes,
heat.
sir.
So, how can we define the good conductors of heat? The materials which allow the heat or thermal energy to transfer easily are called good conductors of heat. And insulators or bad conductors opposite. That's it. We will go for it. We will make the notes first. We discuss all these full learning outcomes. Then we will go for writing the notes together. Inshallah. By this time, I see we have our panel completed, huh? With 7 stars with me, right? All these 7 stars, I am mentioning their name. First of all, Mahi Khan, right? Then Sumaya bint Rahman, Al Farabi, then Mariam Sirajum Manira, Adrita. Her nickname is Adrita, right? Yeah. Then Monica De Silva. Then Mariam Ali, Maimuna, right? So we welcome all of you in our class, and you all say hello to each other because today we got Adrita new, then today we got here Sumaya new, and also
Yes.
Maria Maimuna. They are also should be saying hello to them, right? Al Farabi and others, because Al Farabi he is missing the classes because he was in a village for a long time. So say hello to everyone, right? Yeah,
Hi.
yeah.
Hello.
Hello.
Sir, this is very awkward.
What is awkward? Yeah, say Mahikan.
Hello.
Yeah, say hello to everyone because we are actually the you know all are elements of the society, right? We all should know each other because we are doing class together. That's why we should know. Uh, we should be known to each other, right? Isn't it?
Yes.
Yeah,
Yes,
Yes,
sir.
sir.
that's better. That's make us comfortable in class. We will feel interest to do class. We'll feel interest to discuss. That's very important, right?
Yes, sir.
Yes, sir.
Yeah. So everyone say just a hello, huh? Or you write message in the messenger. Yeah, in the uh, there is scope to write message, right? In your
Yes, sir.
so
Yes,
write
sir.
message. Yeah, that one can be also nice. Okay, at least just say hello so we can know each other, right? At least name. We know each other's name. Later on, we'll have more discussions. Now, second one we have describe in terms of the movement of the molecules or free electrons how heat transfer occurs in solids. Hmm. So this one is again bringing the idea of free electrons. How heat transfer occurs in solids. You know that solid, we have the molecules, they are tightly packed, right? They are very close to each other. So in solids, if we give more energy, we give more thermal energy, then they don't change their place. The molecules stay in their place. Uh, Rather, they pass the energy by vibrating, right? If we give more energy, then they start vibrating more and transfers this vibration to the next molecules. This way, energy is transferred. Okay, this is about all the solids. And especially for metals, they have free electrons. Apart from vibrating the molecules and transferring energy to the next molecules, we have free electrons in metals which are free to move on the surface of the metal, and they are carrying energy also, right? So in metals, we have two two things, two factors in the motion of energy. That's why metals are good, very good conductors. And in all other solids, we have the vibration of molecules, but because of this vibration of molecules, the energy transfer is not that much the way the metals are passing. Okay, even you are taking a piece of wood or plastic, if you are giving too much heat, then after like a certain level, you will also feel hot in those, right? Like the
Yes,
clothes in our house also we are using as insulator. Even we are touching it for a long time on the hot container, then you'll feel the hot, right? Not that much like the
yes, sir.
metal, but you feel hot. That means they are also transferring energy, but not the way the metals are. That's why they are called bad conductors. Okay.
Yes, sir.
Little bit they are passing. And we have some conditions to transfer energy from one solid to another solid. That one is called conduction process. If you touch the spoon, only that time you are feeling the that the heat is coming to you. But if you are not touching, you don't feel that hot, right? Isn't it? So conduction occurs if it is in contact to each other. Otherwise, conduction will not happen. So it is a condition for conduction that the solids, your hand is solid, right? Hello.
Yes, sir.
So yeah,
Yes, sir.
so
Yes, sir.
and spoon is also solid. So from that spoon to your hand to transfer heat, they should be in contact to each other. Okay.
Yes,
Without the
sir.
contact, they will not pass the heat energy. So this is about conduction. So you see in our content we have conduction, right? So
Yes, sir.
conduction is a process of heat transfer which transfers energy from one solid to another by the vibrations of molecules. Okay, this is the
Yes,
process
sir.
of conduction. And there is another process, convection. Convection, it is another process. It is only happening in the fluids. Fluid means, what is called fluid? Any idea?
Sir, liquid.
Liquid. Any
Both
more
gases and
ideas?
liquids, right?
What?
Both gases and liquids.
Both gas and liquid. Okay. So both gas and liquid, they are called fluid. Why? Because they can flow, right? Hello.
Okay, sir.
The gas and
Yes.
liquids both can flow, like air can flow, right? Air,
Yes, sir.
gas, anything can flow. Then water can also flow. This is liquid. So they who can flow, they are called fluids. That's why both gas and liquid, they are called fluids. And convection is only occurring in fluids. We are bringing two examples, very simple examples. You'll understand it easily. Uh, First, we think about the cooking, huh? About the liquid in our house when we are going for cooking food. Where we give the heat, at the bottom or at the top or in the middle?
The
So at the
bottom.
At the bottom. Very good, very good. So why not we are giving at the top or in the middle?
sir, to flow heat
Yeah, here I'm
to
showing
conduct
you.
heat. Sorry,
Yeah.
sir, to conduct heat.
Hmm. So to conduct heat means to convect it. We will say it to convect it. This process is called convection. Uh, how this is
Yes, sir.
happening? Yeah, I'm showing you in the diagram. Then you'll understand it more. Like we have a container like this, and here is water. Here is water. Then we are giving heat here, right? Here is giving heat. Yeah, here is
At the
given heat.
bottom.
Yeah, here is given heat. So we, if we give heat here, then what happens? There is, here we have water, right? Or any other
Yes,
liquid. Yeah, we are cooking. Then this part of water becomes hot first, right?
Yes, sir.
Yeah. First of all, heat is here. This container is solid, right?
Yes,
This
sir.
container is solid, and this container first get the heat, then it transfer the heat to water. So this process, the first step is conduction, because we are getting first the solid, the solid is transferring to liquid, that is conduction. But after the liquid is getting this heat, what happens? This,
convection.
yeah, this liquid when they get heat, what happens? These molecules becomes gaining more energy. They are moving far apart, right? These molecules move far apart. So if they are moving far apart, what happens?
They start to
Their
evaporate.
volume increases, right? The liquid
Yes, sir.
volume increases, and when the volume increases, anything we say, we have less density, right? The molecules move farther apart means their density becomes less, right? They are becoming lighter, isn't it?
Yes, sir.
Hello.
Yes, sir.
So when they become lighter, what happens? They rise up, huh? They rise up. They rise up this way, and when they rise up, this place will not be empty, right? What will happen from here? The cold molecules from here, they will take this place, right? Isn't it?
Yes, sir. Yes, sir.
Because cold molecules, they are more denser, and they will sink down, right? And hot
Yes,
molecules, they are less denser, they rise up. This way, the circulation process, right? There is circulation, okay, circulation of molecules, and the heat is transferred in the whole liquid in this way. Is it clear?
Yes, sir.
So if we give the stove here, for example, we are giving heat here, heat is given here only, not at the bottom. What happens if
Sir,
we give heat at the top? What will happen? Any idea, anyone? Hmm?
Sir, heat won't be spread evenly.
Sorry.
The heat won't be spread evenly.
Yes, very good answer. And heat will actually stay here. Like you are giving heat here. We know one thing that the hot things is lighter, right? Isn't it?
yes, sir.
Yes,
So
sir.
the lighter things will stay up, and the cold things they are the denser they will stay down. So there will be no circulation process, isn't it? The hot things will stay up and the cold things stay down. So circulation process is not happening here in the entire liquid. Only one part is becoming hot, right? Isn't it?
Yes, sir.
Yes, sir.
Yes.
So our condition for convection is the heating element should be at the bottom. Is it clear?
Yes,
Yes,
sir.
The
sir.
heating element should be at the bottom. So this one is not only only for cooking or boiling water, is for everything. Like if you want to have the winter, the cold countries, they have the heater in their room at the bottom, right? Isn't it?
Yes, sir.
Yeah,
Yes, sir.
so that there is circulation of air in the whole room. And another example I will bring, all of you have the experience that one in your school, in your house, that is about the AC. uh, you can remember now, you can recall that AC, even if it is available in your house, you can check it now that the AC is fixed or installed at the top of the wall,
Yes,
right?
sir.
It's not at the
Yes, sir.
bottom, it's at the top of the wall.
Yes, sir.
Why
Because,
we are doing it? Why installing at the top? Why not at the bottom?
sir, because it transfers, sir, um,
Yeah,
cold air. Sir.
yeah, very
So
good.
that the
You
cold
are
air can
trying.
circulate the
Uh,
room.
yeah. So what you are saying, Monica? Can you say again?
So that the cold air can circulate the whole room.
Yes, very good. So that there is circulation of the cold air, the whole room, right? So how it is
Yes,
happening? Like at the top, we have the AC that is making the surrounding
sir,
air
it
cooler, right?
provides, sir, it provides
Yeah.
the cold air.
Yeah, cold air. The surrounding air becomes colder and they become heavier, more denser. They are sinking down, right?
Yes,
Isn't it?
sir.
Yes, sir.
And the hot air from the bottom, they rise up and take that place, isn't it? And this
Yes, sir.
process, this way it is continued. If you install it at the bottom, what will happen? The AC, if you install at the bottom, the cold air will stay in a single place, right? At one place.
Yes, sir.
There will be no
Yes,
circulation. There will be no circulation, right? So
yes,
for convection process, we have to fix or install the cooling element at the top.
Yes, sir. Upper side.
Yeah, upper side, exactly. Is it clear now? Yeah,
Yes,
Maimuna,
sir.
Mariam got disconnected, right? She got
Yes, sir.
problem with network maybe, or any device.
Mm.
Okay, so we have here uh, the learning outcome C is also done, right?
Yes,
Now
sir.
discussion is done. We will write all together all the notes later in the second meeting. We'll write everything. Now D, learning outcome D, the third process. We discussed about two processes of heat transfer. One is conduction, another one is convection, and now the third one is radiation.
Radiation, sir.
Okay, so in our daily life, we have one experience every day. That is during the daytime. During the daytime, uh, the sun's heat energy we feel, right?
Yes,
Isn't
sir.
it? During the night time, it is very cold, right? But during the daytime, it's not that much cold. Why? Because of sunlight. Huh? Sun is giving us heat energy. So where is sun? Sun is very far from us, right?
Yes, sir.
Yes, sir.
So in between the sun and the earth, there is long distance, and uh, in this distance there is, you know, space, right? There is no medium
Yes.
available, right? No air. Like after the atmosphere of the earth, the sun is very far, right? Isn't it?
Yes, sir.
Yes,
And
sir.
between the earth and the sun, we don't have any medium available. No solid, no liquid, no air, no fluid, right? Nothing else. Isn't it? Is
Yes,
there
sir.
anything?
No, sir.
No, sir.
Only vacuum, right? We say vacuum, right? Nothing is there.
Yes.
Even after that, we are getting heat energy. What is the process? We know heat is transferring by
Radiation.
conduction. They should be in contact to each other, right? Sun is not in contact with each other, right? With the earth. So there is
So
no
one kind,
conduction. Sorry?
so one kind of radiation.
Yeah, radiation. So there is no possibility of conduction. There is no possibility of convection, right? So what is the
Yes,
Yes.
sir.
process? The process is radiation. So
Radiation.
radiation is the process in which the heat is transferred without the help of any medium, neither solid nor fluid, right? Only heat is
Yes, sir.
transferred uh, directly, right, without the help of any medium. So this process is called radiation. Okay.
Okay,
So
sir.
Yes, sir.
in our
Yes,
next
sir.
meeting, we will discuss more about all this, and we will have the notes, inshallah. So you join, join after uh, mm, 45. You join, 7:45, all of you. We have here Salatul Isha break,
Okay,
7:45.
sir.
Will join all. Okay. Thank you all.
Sir.
Assalamu alaikum, sir.
Walaikum salam.